Right, try 4. This suggests that we can use the Pythagorean theorem to find missing side lengths. The first example, notice that I do have a right triangle. I must have a right triangle to be able to apply the Pythagorean theorem. I'm given 3 sides. Let's refresh what the Pythagorean theorem itself says. It says that a squared plus b squared is equal to c squared. Now that holds true as long as whichever values are necessary are plugged into the right place. And while this could be a, or this could be a, this side cannot be a. This side is the hypotenuse. It must be listed as c. So I'm going to choose this to be my a. That squared plus the other leg squared should be equal to the hypotenuse squared. Simplify whatever values I can. Subtract 9 from both sides. Take the square root. Now, when I take the square root, theoretically, I should end up with a positive and a negative value, because there are 2 numbers that multiply together to make 16. Negative 4 times negative 4 makes 16, as well as positive 4 times positive 4. However, because we're talking about the lengths of a geometric figure, the negative value doesn't make any sense. So we're going to say, in this case, x equals positive 4. That's our solution. That's the length of the missing side as suggested by this skill. Right, try 4. Second one, very similar problem. Again, I have to identify which side is opposite the right angle. That's my hypotenuse. That's going to be my c squared. The other 2, it doesn't matter what order I put them in. Okay, so y squared plus 16 is equal to 64. Y squared is equal to, subtracting 16 from both sides, I get 48. So y is equal to square root of 48. Again, it should be a plus or minus because I'm dealing with a length. I know I'm not concerned with the negative value, so I'm just going to use the positive value. To simplify the square root of 48, I'll use a factor tree. See who's hooking up. 4s are hooking up, they get to come out, leaving a 3 on the inside. In other words, this length is 4 root 3 units long. Third example, more complicated because this time we're missing 2 sides. Now, Pythagorean theorem has 3 variables in it. Unless you can reduce that to 1 variable, you cannot solve that. In this case, the same variable is used for the missing sides. First, identify the hypotenuse. Add together a squared plus b squared. Now, this one is more challenging for an additional reason besides that. These add together. If I have 1x squared and I add a second x squared, I have 2x squared. But how do you square 5 root 2? Well, that's the same thing as 5 root 2 times 5 root 2. The commutative property of multiplication suggests that we can move things around as long as it's all multiplication. And this means 5 times root 2 times 5 times root 2. So I'm going to restate this as 5 times 5 times root 2 times root 2. 5 times 5 is 25. Root 2 times root 2. Well, you can think about that as either root 4, or the fact that we're squaring a square root undoes that value, making it just 2. Divide both sides by 2 to solve for x squared. Take the square root of both sides, we get x is equal to 5. In other words, the length of these sides are each 5, such that it becomes a 5, 5, 5 root 2 triangle. Of note, remember that when 2 sides are congruent, that suggests this triangle is an isosceles triangle, which makes the base angles also congruent. This is a 45, 45, 90 triangle, which we'll be dealing with in greater depth later. Fourth example. This one's more challenging. Notice that this side is not listed as an unknown. However, in order to find this side, I need to have these 2 other sides. I've got the 12, but I'm missing this side. So this is an intermediary unknown. I'm going to solve it using the purple triangle. Let's call it A. So a squared plus 20 squared is equal to 25 squared. Notice that I had to isolate, first of all, which one is opposite that right angle to identify which one goes alone. That's the hypotenuse. Simplify. Square root. Now I know that this triangle exists with a hypotenuse of 15, a leg of 12, and a leg of x. I can set up my Pythagorean theorem a second time, because the hypotenuse is over here, that's my isolated term. In this case, the missing value is x is equal